Lesson 98, we're looking at ellipses. Um, ellipses are one of our four conic sections. A conic section is a slice that occurs when we go through a right cone. We've already dealt with one of them a lot already this year. The first one was a parabola. The second one we dealt with was a circle. The third one that we get into today is the ellipse. And the fourth one that we'll get into here next week is called the hyperbola, which is basically a double parabola. If we take a look at our right cone that we have here, now imagine if you would, here's the bottom right cone. When we do a conic section, there's actually another right cone right above it. So there's the first one, there's the second one right above it. They're at tip to tip. Okay. The first conic section, the parabola, if you would take a sword to it. And if we cut it at an angle here, and we slice it off and open it up, what shape do we see? This is a parabola, right? Assuming that the cone would go downward forever. Okay, there's your parabola. If it was upward, going this way, this would be a parabola going upward. All right, that was our first conic section. If I take a sword and go perfectly horizontal with it, open it up, what shape do we see? Circle. Okay, that's our second one. The third one that we get into today is when we go at an angle all the way through it. Take that one off, and we open it up. What shape do we see there? Some of you would say an oval, and the technical name for it is an ellipse. Okay. The hyperbola we will talk about next week. Okay, so we're looking at the ellipse today. Okay, that is the oval shape to it. Good example of an ellipse is if you were looking at the two-dimensional view of a football laying on its side, maybe it's sitting on the tee. You got 2 points that are further away from one another as opposed to the two closer ones, which are the co-vertices. Here's the definition of your ellipse. Don't bother with copying it down. It's going to confuse you more than anything. But here are some of the terms that we're going to be focusing on today that go with the ellipse. First one is the foci. That's how you say that. And basically, it's the foci that generate the ellipse. Now, I will not, when we graph it, we're going to be graphing two vertices and two co-vertices as well as the center. Kind of like with what we did with the circle, right? We identified the center of the circle and then our 4 points around the edges. It's really the exact same concept. But I got a YouTube video that I'll show you later that further demonstrates where the foci come into play. We have this thing called the major axis as well as the minor axis. And then we have this term called the eccentricity at the very end. Here's what you need for your notes is this box right here. This is the standard form of the equation of an ellipse when it is centered at 0, 0. So we assume that it is centered at the origin. Now when we look at an ellipse, again, the football could be laying on the ground, or it could be set up on its end and it's sitting on the tee. That's the difference between saying that the major axis is horizontal as well as the major axis being vertical. When the major axis is horizontal, that's when it's lying on the ground. When the major axis is vertical, that's when it's sitting straight up on the tee. So we have two different equations that we could use. It's all based on, well, where's the major axis? Is it horizontal or is it vertical? If it's just horizontal, we're going to be looking at this left side, and we can disregard the right side. If it's vertical, we'd use the right side and forget about the left side. Okay? So you're not always going to use both sides, you're going to use one half or the other. If the major axis is horizontal, this is the template that we will use to find the vertice, the foci, as well as the covertice. And the same thing if the major axis was vertical. There's our equation. There it is for the vertice, the foci, and the covertice. I'll give you a minute to go ahead and finish copying the chart. Right below the chart, I would include these two diagrams because the visual of it will be very, very helpful. Let's start with the major axis being horizontal. Again, if the major axis is horizontal, is this when it's laying on the ground or setting up on the T? When it's laying on the ground, right? This is when our ellipse is wider than it is taller. Wider horizontally as opposed to being that one. So if the major axis is horizontal, first of all, this is your major axis. And then we would say that this one here is our minor axis. The vertices will always fall on the major axis. And they tell us the vertices are always going to be at a comma 0. Negative a comma 0. The covertices will always fall on the minor axis, hence the reason why we call them covertices. Those locations are 0 comma b and 0 comma negative b. Center is at the origin, and your ellipse will always be symmetrical through the center, both vertically and horizontally. The foci, that's your C value. Those also go on the major axis. You don't really need the foci to graph the ellipse. But again, the YouTube video later on will better demonstrate just how we use the foci to generate this thing. Vertices, covertices. If we do the same thing with the major axis being vertical, now our vertices are going to be here and here. Covertices are going to be on the x-axis, centered at the origin. If we label our points, the vertices, 0 comma a, 0 comma negative a, b comma 0, negative b comma 0. Foci, 0, negative c. Major is the y, the minor is the x. Now when you graph these ellipses, really the only thing you need to identify are the a, b, and c values, and then also the h and the k when we get into it when it's not centered at the origin. For example number 1, one thing that I forgot. Notice, what are both equations set equal to? 1, right? The ellipse is always set equal to 1. So make sure you're cautious of that. We want to write the equation in standard form for the ellipse when it is centered at 0, 0. Now let's go ahead and identify the vertices and the co-vertices. Vertices are going to be these points right here. Co-vertices are there and there. They tell us the major axis is the x, the minor is the y, which makes sense. The other thing that I forgot to mention to you is the fact that the a value will always be greater than the b value. So I'm going to put it right here. A is always greater than b. And it's identifying your A and your B value, which is going to identify whether this thing is going to go horizontally or vertically. We know that the major axis is horizontal because it's longer this way. The football is lying on the ground. So which one of the two sides are we going to use? Well, we're going to use the left side. Okay? So our template for our equation is going to be x squared over a squared, y squared over b squared. My a value always correlates to my vertice. If I look at my a value over here, it would be 4, 0 and negative 4, 0. Therefore, what's my a value? Well, it's 4. My b value always correlates to my co-vertice. 0, 2, 0, negative 2. Therefore, my b value is going to be 2. Therefore, when we write this thing, all we got to do is plug it in. And again, it's set equal to 1. That's going from the graph to the equation. What they're going to ask you to do a lot of is go from the equation to the graph. Before we do that, there's a couple of other things that we need to put in our notes. There's not a c value in the equation, so we actually need an equation to solve for c. And there it is. It's c squared is equal to a squared minus b squared. It almost looks like Pythagorean theorem, am I right? Close, except now we're subtracting the two instead of adding. The foci is always with that c value. If you go back to your chart or your formula or your template, you'll find that the foci is directly to the c value. And this eccentricity, don't get too caught up in that term. Just know that you find the eccentricity by taking the c value and dividing it by the a. Alright, so here we go. Good example for your notes. The equation that they give us is 25x squared plus 9y squared equals 225. We want to graph the ellipse. We want to find the vertices, co-vertices, and the foci. They also want us to calculate the eccentricity. What did we say the equation had to be equal to? 1. This one's not equal to 1, correct? So the question becomes, how are we going to set it equal to 1? Well, we're simply going to divide everything by 225. And I know that because 225 over 225 is going to be equal to 1. Now we got to simplify on the left side a little bit. How many times does 25 go into 225? Well, it'd be 9 times. How many times does 9 go into 225? 25. So y squared over 25. Now the last thing we want to do is we want to get these to have exponents of 2, right? Because if you go back to your template, we can identify the a and b values as if we have those exponents of 2. So x squared over 3 squared plus y squared over 5 squared is going to be equal to 1. So there is the equation of our ellipse in standard form. We have it set equal to 1. We have the x and the y's. We also have these denominators to have an exponent of 2. The next thing we can do is go ahead and find our a, b, and c values. So we know our a and b value is either going to be 3 or 5, right? Or vice versa. We always said the a value was the greatest of the two, correct? So what's our a value here? Well, it's going to be the 5. What's the b value? Well, it's that 3. Is everybody okay with that idea? A value is always the greater of the two. Okay? How do we find the c value? Well, we go back to c squared is equal to a squared minus b squared. If we do the scratch work up above, a value is 5, b value is 3. We find that the c value is going to be equal to 4. And really, now that you have A, B, and C, the only thing left to do is to identify, okay, is the football lying on the ground, horizontal, or is it sitting on the tee where it's vertical? How do we know? Well, if you go back to your template and your chart, notice that where was the A value located underneath here for the horizontal part? Under X or Y? Well, it's under the X. Let's go to the major axis being vertical. Now where is your A value located? It's under the Y. The greater the value will always occur under either X or Y, and that's going to determine whether it's horizontal or vertical. So if we go to this one, greater of the two value is 5, so that's my A value there. Which variable is it under? Y. Therefore, horizontal or vertical? Vertical. So when we go back to our chart or our template, this is the side that we need to use. Make sense? We can disregard this side because it's not horizontal. So, because it's vertical, okay, our vertices are going to be 0, A, 0, negative A. Co-vertices are going to be B0, negative B0, and the foci are going to be those. So let's go ahead and generate those. Vertices. And now it's just substitution. What did I say my A value was? Well, it was 5. So the vertices are going to be the ordered pairs 0, 5, and 0, negative 5. What's my co-vertices going to be? What's my B value? 3. Therefore, it's going to be 3, 0. And negative 3, 0. C value, if we wanted to, for the foci, 0, 4, 0, negative 4. The vertices and the co-vertices are the 4 points that I want you to plot. If you plot the foci, that's okay. That's just kind of some extra. So we said we're centered at the origin. 0, 5. 3, 0. Hope I plot those right, huh? 0, 5. And that's what I need to see come test time. Or homework quiz time. 5 points, just like your circle, you got to identify the center. You need to identify the 2 vertices and the 2 co-vertices. Foci, don't worry about graphing those. Let's go ahead and get this copied before we take off for lunch. The only thing is, everything that we've done up to this point is when the ellipse is going to be centered at the origin. We can move this thing throughout the coordinate plane, right? So maybe it's not centered at 0, 0, but instead it's going to be centered at h comma k. Very similar to your equation of a circle, am I right? This was the equation of the circle. There was your center, hk. So they're using the same variables, h and k, to identify that center location. We still have the same idea of major axis being horizontal or vertical. If it's horizontal, the a value is going to be located under the x. If it's vertical, the a value is going to be located under the y. Again, the a is always the greater of the two. Now they're just throwing in h and k. And unfortunately, when we start moving this ellipse around throughout the coordinate plane, it's obviously going to mess with our vertice, co-vertice, and foci. So that's why they look a little bit different. This template to identifying your vertices, co-vertices, and foci looks very complex, right? But at the end of the day, here's what you'll do. You'll identify your A, B, and C like we did for example number 1, and then you'll also identify your H and your K. Once you identify those 5 pieces, you plug them in and simplify. Need more time, or are we ready to move on? You're done? Yes? No? Alright, so here we go. Example number 3, they want us to draft the following equation, identify the vertice, co-vertice, foci, as well as the center because it's not going to be at the origin anymore. Also calculate the eccentricity if we want to. Let's begin by putting this thing into standard form. Again, even though it's not centered at the origin, what are all these set equal to? 1. So let's repeat that process. Notice this thing is set equal to 576. So what are we going to do? Well, let's divide both sides by 576. So now I know the right side is equal to 1. 9 goes into 576 how many times? Well, I believe it's 64. $64 goes into 576 9 times. So therefore, the equation in standard form will look like the following. Write it with an exponent of 2, set equal to 1, and we will finish this when we come back.
Did you watch them poke yourself?
For those of you watching the video, go ahead and go to the notes that are online, just the regular lesson notes. You'll find those on Canvas, and then you can see how we filled in the rest of the pieces. Go back to your chart that we have up at the top. Look at your major axis versus vertical. If you look at this equation, notice your A value is going to be the 8. Therefore, the A value is located under the X variable. So when determining horizontal versus vertical, here the A value is located under the X, so this thing is going to have a major axis as horizontal. Therefore, you'll use the left side of the boxes as opposed to the right. Good luck.